Okay, ladies and gentlemen, so what we're doing is we're taking this on another level. Max has already started, so he's already got it, so he's going to be way ahead anyway. Okay, but what we're doing, we have at the moment been able to look at patterns like this, right? And if I said to you, Magnus, how many terms in that sequence so far?
There are 4.
There are 4 terms. So if I said to you, Ryan, give me the next 2 terms of that sequence, you would tell me that the next 2 terms of that sequence are?
Add 2, which would make 11, and then add another 2, which would make 13.
Okay, so you found that by looking at what happens each time, so we know it's always add 2, so we followed on from that rule. Okay, so we've done that. Right? Right? Everyone's happy. So the rules could be like this. It could be a rule like this.
Which is plus.
Okay. So if I said to you, Tamar, give me the next 2 terms of that sequence.
So it's the first one is plus 2.
Yeah.
Then it's plus 3. Then
Yeah.
it's plus 4. So it's always plus 1 more. So the next one that would be next one would be 18.
Because it's plus
5.
Right?
Plus 6.
And then plus 6, that would make 24.
Okay. So we've got sequences like that too. We've also got sequences that go something like this. Right? So, ideally, what's the rule from getting to the next one term to the next term? What do you do each time?
Times by 3.
So we always times by 3. So times 3 times. So we can always have a times 3 one as well. So who can tell me what the next term would be without a calculator?
What?
That's easy. 30.
Oh, wait.
That is? Nope.
60.
Wait, 64.
No.
Wait.
You try. Yeah, do it like that. Matches? No. 71? Close, not quite.
81.
81, right.
She was looking out on a paper.
That's alright, you just said without a calculator. You've all got methods for calculating on paper. What? I didn't say you shouldn't do it.
Oh.
What's the next term?
Oh, no.
Really easy, actually.
Oh, that's easy.
Oh, yeah, it's 3, and then 8 is 24. So 243.
243, yeah. That would be the next term for that.
And then the next
I
term.
thought it was, because remember that 3 times. What?
Because what Dillo did was 3 times 1 makes 3, and 3 times 8 makes 24.
So
but it's actually 80, so it's 240 with the 3. Okay? So it's those practicing those rules. Right, now.
Plus 729.
So, we've got these rules. We then took it a step further, alright, which was, we had rules. We were given rules. For instance, one like this, 3n plus 1. And I said, well, we've got to, let's write the first 6 terms of that sequence.
So the first 6.
The first 6 terms. So,
So 3 times 1.
so that would be, yeah, go on.
3 times 1 plus 1
So 3 times 1 plus 1
equals 4.
equals 4.
3 times 2 plus 1,
Yeah.
which is 7. 3 plus 3 plus 1 equals 10.
It's 3 times 3, not
3
1.
times, sorry, 3 times
Yeah.
3. 3 times 4 plus 1, which is 13. And 3,
Oh, sorry.
3 times 5 plus 1 is 16. 3 times 6 plus 1. Oh yeah, there is a pattern and it's an
Yeah, I think that's it. So, but before we do, we know that that is the way to find, so that's no problem. but then we discovered there's a shortcut really. So this one is always going to be add 3 every time. So once we've worked that out, we can go probably quicker. So we can work out what the first one would be, and then is there any way that we noticed how to identify what it was going to be, whether it was going to be add 3 or add 5, or right?
Because it would be 3 times 3.
Yeah, because the 3 here, the 3 times, okay, well it makes sense. If it's always 3 times, like 3 times 1, 3 times 2, 3 times, that is the same as adding 3 on every time, isn't it? It's the 3 times table. Then you always add 1 afterwards, but that's not going to change because they all add 1. So we know that from 3n, that this term is always going to be plus 3. And that's something we're going to be using. Yes, Tamar?
But like for the exercise we did above that, what if it's a really hard pattern? What if it takes 4?
Right, now that's a very good question. If it's one like this, it's a different type of pattern. So we're actually limiting ourselves to what are called, right? These are called, at the moment, we are only working with arithmetic sequences, okay? Or they're also known as linear sequences, and that's because they're arithmetic because we always add the same amount every time. They have what we call a common difference. And the common difference in this case is plus 3. Alright? Now, you're right. The ones up here, the times 3 is a different type. Just out of interest, you don't need to worry about this at the moment. This is called a geometric sequence because it's always multiplied. Okay? And then the plus 2, plus 3, plus 5. This is going to end up being a quadratic sequence. But they're the kind of ones that we'll get into, in years to come. But what we do need to be able to do is we're going to work on just these linear sequences that always go up in the same amount.
Like, how do you find out if it's like times 3 divided by 2 plus 2?
But it's not going to be a random thing. Then it's not a pattern thing. Remember, we're looking at sequences that follow easily identifiable patterns. Yeah? So what we're doing, let's get back to this one with 4n minus 1, for instance. If we wanted to work out the sequence, what we could do is say the first number is 4 times 1 minus 1, which makes 3. But then the next term will be 7.
Oh, okay.
9.
9.
Think about it.
10.
11.
And then 15. 19. And then 23.
So, there's the first 6 terms. I know it because, as we've already said, it's 4 times, so that means it's going to be plus 4 every time. Now, we're kind of going to use that, that we know, to help us, rather than go from this general rule. So this is called the general rule for the nth term. Okay? And that's how you create the sequence. And if we go back up to our objective, we want to be able to determine the general rule for the nth term of the sequence. So rather than what we did before was use the rule, we want to find what the rule is. Okay? Understand the difference? So we've got to go the other way. So if I, for instance, gave you a sequence like, we'll go 5, 7, 9, 11, 13, and so on. If I asked you to write down what you think the general rule for the nth term was, right, with explanation, right, what would you tell me you would have to do, right?
I think it would be 3, 4n plus.
What's your reasoning for 4n?
Because 4 times 1 equals 4, and then if you add 2 equals 5, then
4 plus 2.
No, 4 times, wait, no, I meant 4 times 1 equals 4, add 1.
So you think 4n plus 1, because that makes 5. Well, does 4n plus 1 also make 7?
Yeah.
Does it?
No.
So 4 times 2 plus 1 doesn't make 7, it makes
9.
So that one doesn't work. Now what I think you didn't use this thing that we know, which is that if it's 4n, the numbers have to go up in 4s. Does this sequence go up in 4s?
It goes up into
So, what do we therefore know it's not going to start with? 4n. So,
it would be 2n.
So we know it's always plus 2. Sorry, I don't know what I've written there. Hang on. So we know it's always plus 2.
2n plus
Hang on. So always plus 2. So that gives us our clue table that the rule will start with 2n. Alright? Because it's always plus 2. Remember? The plus 2 means that's what goes before the n. Yeah? Easy enough?
Yeah.
Right. The thing is though, that's not quite finished because 2 times, so it's got to be 2 times 1, which is not 5. So we're not there yet. Then we've got 2 times 2, 2 times 3, need to be these answers.
Add 3.
So 2 times 1 is 2, but we need 5. So if we added 3, that would work for this one. Does it work here? 2 times 2 is 4, add 3. 2 times 2 add. So that looks like what it is. So we've got 2n, add 3, would appear to be the general rule for that linear sequence.
That's easy.
Yeah. Quite easy. Let me give you one more before I let you write your notes. So, give you one that make you think a bit more. So if we got 11, 7, 3, minus 1, and so on. It's a hard one. You know it. Taylor, what do you think?
Oh, that's
3, wait, so like 11 could be like 3n plus.
Why 3n?
Maybe like 3 because it works for the other.
It worked with that sequence, but we've got a new sequence.
Oh,
Sorry?
I think it would be 7 because 7 times.
You're guessing again. What's the thing? We have to look at what happens from term to term. What is it?
Minus 4.
-4 every time. Every time it's -4. So, what goes here for this sequence? It will be
7 times.
-4n. Well done, Magnus. I didn't expect you to get that straight away, actually. You just take this number as -4 times n. Because that's what we have here. Subtract 4 every time. Okay? Now here's where it gets really tricky. You have to know your negative numbers. So, -4 times 1 is what?
Minus 4.
-4. But we need 11. So how do I get from -4 times 1 is -4. But I need to go from -4 to 11 because that's what's here. So what do I have to do to -4 to get to 11? Add 15. Yeah? So from negative, imagine it's temperature, -4 up to 11. What about here then? So this would be -4 times 2 makes?
It makes minus 8.
Makes -8. But if I'm at minus 8, I need to get to 7.
Plus 15.
If I add 15, do I get to there?
Wait.
Yeah.
Yeah.
I do. So we reckon minus 4n plus
15.
15 is the right.
Ooh.
So the important thing that a couple of you have not quite twigged onto. First off, find what's called, and I've already told you the name for it, the common difference. Find the common difference. That goes here, next to the n. You put an n in. Then you've got to figure out what do you have to add or subtract to make the terms right. No, well, there is no next one. Oh, you mean the next number? The next number is? Minus 5. The next one?
Minus 9.
Minus 9. Okay, can I get you then, guys, to write down those notes and make sure you understand? Okay? Okay, guys. Right, let me. Again, because like I just said, there's something that everyone does wrong in a test. Right? Well, I say everyone, not everyone. At least one person every time. Even when I say someone will do this, it doesn't stop people doing it. At least one of you, I think, will do this. Unless I taught it very well and you studied. The nth term rule. So come test, this is what happens. So before we go through what the answer actually is. So everyone remembers, oh, it's plus 3, plus 3, plus 3. They remember to do that, that's fine. And then the rule they write down is this. N plus 3. That's what they do.
Oh, why would you do that?
Because they forget what you're supposed to do with plus 3. And they think, oh, it makes sense. It's always add 3, so this must be n plus 3. But of course, then this one would be n plus 7, and this one would be n plus 8, and this one would be n plus 3. Now, here's the thing. How can this be n plus 3 and this be n plus 3 when they're different sequences?
Oh, I know number 2.
We know it's not n plus 3 because n plus 3 would give a first number of. Guys, can you go ahead to table?
4.
Table.
Yeah.
Quick pen down. Okay, this is the learning bit now. Okay. What would n plus 3 give you for the first number?
4.
4. So we know it can't be right. Right? So people always do that. So that is one thing I want to tell you. It might be right, but do not assume that that is the answer, because plus 3 is not n plus 3. We know that instead of n plus 3, plus 3 means it must be 3n, yeah? And the next one must be, Magnus?
So the next one is, it's 7n.
I don't want the rest of the answer. Just 7n. The next one will be 8n.
8n.
The next one will be
3n.
3n. If I go down a bit more, this one would be 3n. This one would be 3. Look how many 3n's we've got. But they're all different sequences. So now, the plus 3 means 3n. But now we've got to figure out the difference. Okay? Alright? So, this first one, we check. 3 times 1 will give me 3. So it looks like I don't have to add anything on. So just check.
3
times 2. So this one, fine. As it is. This one, 7n. Well, we do 7 times 1 gives me 7, but I need 5, so I have to subtract 2. So I just check. 7 times 2 is 14. Subtract 2 makes, yeah, we think that's right. So subtract 2. Alright? The next one, it's 8n. Fine. Then we do our 8 times 1 makes 8. But I need 21, not 8. So I have to add 8 plus what makes 21? 13, you think?
12. No,
12.
13. No, it's 13.
13.
Yes, 13.
Plus 13. So we think plus 13. Let's just check. 8 times 2 is 16. 16 plus 13, 29. We're happy with that. Right? This one, 8 to 11 is 3n. But again, what are we writing, guys? Let's just wait a minute. Come on. 3 times 1 makes 3, so we have to
Plus 5.
plus 5.
This is actually quite.
And finally, the one I'm going to check with you. Please don't move your stuff, Dave. I'll put it down. Right? This one, we know it's 3n, so 3 times 1 makes 3.
Minus 2, minus 2.
So we have minus 2.
Okay.
Okay? Got it?
Okay.
Okay, we'll go through the rest next time.